All right, this is the finest physics problem ever written. Okay, so the first thing we got to understand is what this is, right? So the drop tower, it free falls for 2.2 seconds, strikes an airbag that slows it to rest in a vertical distance of 3.2 meters. How fast does it strike the airbag? What is its upward acceleration as it stops? And what is the upward force acting on the experiment to stop it? Right. So let's just understand what this is. First, you've got this package that we're going to drop, right? The package falls for 2.2 seconds, some distance, right? And here it is, at the end of 2.2 seconds. It's moving down. You can see those little lines there. I mean, it's moving down, right? And it strikes this airbag, right, which is like this big inflated bag inside a cylinder like this, right? And that airbag slows it down over some distance of 3.2 meters. Okay, so we're going to solve the first two here. Let's do that, right? So the first thing is, how fast is it going when it hits this airbag, right? We can SUVAT that, right? So we can SUVAT. The initial velocity is 0 because it free falls from rest, right? 2.2 seconds. And then the acceleration is negative 9.81 meters per second squared, right? So I'm going to choose v equals u plus at. So it's the final velocity, which we're trying to solve for, right, is 0 plus negative 9.81 times 2.2. Okay? So now we're all set. 9.81 times 2.2 is approximately 21.582. Negative, right? So the final velocity is negative 21.582. Okay, so there's that answer, right? Now we're going to get this guy here, is what's its upward acceleration as it stops, right? So now we're looking at the part where it hits the airbag and it's brought to rest. That's this 3.2 meters down, right? So let's do that, okay? So now, let's see, what do we know? We know the displacement is down. It goes down 3.2 meters, right? That's the thing there, right? The initial velocity is now this velocity right here, where we hit it going this fast. So negative 21.582. Final is 0 because, of course, we want to stop this thing. And the acceleration we deeply care about, right? So I'm going to choose the formula v squared is u squared plus 2as. Okay. So 0 squared is negative 21.582 plus 2 times a times negative 3.2, right? And now we're set. We put this guy on this side here, right? And we get a negative, and then we're going to divide by a negative, and we'll get a positive acceleration, which, of course, if you stop moving down, you're accelerating positively, right? So we know this. We know it's going to be a positive acceleration, right? So the 21.582, I square that. It's now a positive number. I put it on this side, it's now a negative number, right? So I've got negative 465.78. That's this thing squared, right? And a bunch of change, right? Equals 2 times a times negative 3.2. The negatives are going to go away, and we'll get a positive acceleration, right? So we go that guy divided by 2 divided by negative 3.2. Okay? And I get 72.77855. Okay? Now, I'm going to use that number, the acceleration of, in this part here, right? I'm going to use that acceleration of positive 72.77855 in the next slide, okay? I got to erase. I need more space, right? So now we're going to draw a little picture. Here's the package. It's slowing down. There's a force upward that we want to find. The force of gravity is still acting downward on it, and as it's slowing down and stopping, it's actually accelerating up at 72, positive 72.77855, or however many sig figs we want to carry, right? And now we just have to solve for some things. It's 118 kilograms. So the downward force is going to be 118. Hold on. Okay, 118 times 9.81. Okay, so this downward force, I'm using weight equals mg. So 118 times 9.81 is equal to 1157.58. Okay, so this downward force is, well, I'm going to say negative 1157.58. All right, the upward force we'll say is positive. You always make unknowns positive, right? And now our F equals ma looks like this. We're using F equals ma. So the sum of the forces is force minus 1157 equals 118 times, okay, crazy positive 72.7785. Now, don't worry about the fact that it's going down, right? It's accelerating up. It's slowing down and stopping. If you are moving down and you slow down and stop, you accelerate up. Okay, so now all I have to do is go this guy plus this guy here. So that guy plus, add this to both sides, right? So plus 118 times positive 72 point all that stuff, right? And I get that the force is equal to 9745.45. I'll just say it's 448, all this stuff, right? Now, law requires us to round to 3 sig figs, so we have to say 9750. Ta-da. And that's an upward force. Yay.